Hello and welcome to another video. Um, we are continuing with the O-level math syllabus. We had done factorizing a difference of squares in the last class. Today what I have for you is factorizing by pairing. Let's see how far we go into this. Okay, this is a topic that is sometimes of concern to a lot of people. We don't remember it explicitly. We remember a square minus b square, and we also remember um, breaking the middle term and all those things if you've done the syllabus once. But factorizing by pairing is something that we often forget. So I would want you to remember this specifically and look at the past paper questions that I have later on. Okay. What pairing involves is whenever you are supposed to do pairing when you have a set of four terms. Okay. So if you have four terms, it's always going to be factorized by pairing. That is what you essentially also do when you are doing factorizing quadratic expressions. Okay. So AB plus 7A and 6B plus 42 are the two pairs that I'm going to factorize. Now, from the first pair, if you see I have A common, so I'm left with B plus 7. In the second one, I have 6 common, so I'm again left with B plus 7. Okay. Now, these are two pairs that I have factored out commons from. What do I do next? Now, remember that these two brackets are now common. So, what I do is I take the bracket common and I write the remaining terms A and then plus 6. So that is called factorizing by pairings. Remember that this bracket must come out common. If it's not common, then you can't factorize incorrectly. Sometimes you may also have to shuffle around the terms for it to show you a common. Okay, let's look at this. 3px minus 2qy. There's nothing common on that. Okay, that's one thing that you have to be careful about. So if there's nothing common in these two terms and then there's nothing common in these two terms, then there's not much that you can do. But can you switch around the terms and say that 3px plus qx minus 2qy minus 6py? So it's now common, x is common. So 3p plus q. You would also arrange the terms differently. And then there is a minus 2y that's common. So I'm left with q plus 3p. Now you see these two brackets are the same. So 3p plus q and x minus 2y. Similarly, for the last one, I see 4a is common. I'm left with 2b plus y. 2x is common. I'm left with 2b plus y. 2b plus y and 4a plus 2. Okay, this question also comes up as it is on your questions as well. So this is the 4024 paper 01. So this is paper 1 question. You see this bracket is now common. So what you can do is you can pull the bracket out common. What are you left with? There's nothing here, so there's 1. The 1 is left from the first term. And what is there from the second term? Minus 3c. That is how you would factorize this completely. Simplify. There's no other simplification I can think of except expansion. There's no factorization happening here. Okay, so this is as far as this goes. Expand and simplify. Let's expand. The x gets multiplied with this entire bracket first. And then minus 1 gets multiplied with this entire bracket then as well. X cubed plus x squared plus x minus x squared minus x. Second one says factorize. So there I see 4 terms. So I'm going to do factorizing by pairing now. What's common to the first two? X, a minus b. minus 3a minus 3y, sorry, minus 3y, a plus a minus b. I have to make sure that the brackets turn out common, which is why I factored out a minus, so that this sign changes to a minus as well. So I have to make sure that this bracket and this bracket are then the same. So I'm left with a minus b as the common bracket. What is left from the other two brackets? X. Okay, this leads us to factorizing quadratic expressions. There's a quadratic expression contains a term in x square and no higher power of x. So 2x square and then x square plus 5 is also quadratic. 3x square plus 7x is also a quadratic expression because its highest power is square. And this is also a quadratic expression. Okay. To factorize the quadratic expression, we can use this result. Okay. What does this result tell you? That the middle term is the result of adding two coefficients together. This gives us a clue for finding the numbers a and b in the two bracketed factors. The product ab gives the constant term in the quadratic expression. So this is 5. That should give me, and a plus b should somehow give me 3. Okay, if that's possible. It's not necessary that every quadratic expression could be factorized. To factorize x square plus 11x plus 30, for example, we look at two numbers with a product of 30 and a sum of 11. So you have to find two numbers that multiply and get you plus 30 at the end, and plus 11 by addition and subtraction. You see this? A plus b. Okay. So the two numbers that I've thought of are 5 and 6. Let's try doing that rather than just thinking about it directly. Okay. So what you do is you write your question. I'm again repeating this one. So I think of two numbers. Now, how do I think of these two numbers? I start making pairs that multiply and get me 30. So 1 into 30 gets me 30. 2 into 15 gets me 30. 3 into 10 gets me 30. 4 into nothing. 5 into 6. And then 6 into 5 is a repetition. So I need to pick a set of numbers. They certainly multiply and get me 30. But do the add up and get me 11. Yes, these are the factors that get me 11. What you do is you write this 11x as a broken middle term. So I can write it as 5x plus 6x. Right now in any order, that doesn't matter because the signs are also smooth. Okay. Then what you do is you factorize by pairing. What's common to the first two? What's common to the other two? 6. You see the bracket has come out as the same. So I get x plus 5 and x plus. Okay. Let's think about a couple of others. Let's start with C here. Okay, let's think of two numbers that when multiplied get me 24. Okay, all of these numbers end up and give me 24. 6 into 4 is going to be a repetition. Now I need two numbers that should add or subtract to 5. So the only numbers that have a difference of 5 are this 3 and 8. So I have to arrange them in I have to break this middle term in such a way that I get minus 5x. So my thought process is x plus 3x minus 8x would give me minus 5x, and then there's a 24 at the end. So what has happened is that this middle term has gotten split into two. 3x minus 8x is minus 5x, but I've done this. Why? So that I can then factorize by pairing. What's common? X is common. What's common? Minus 8 is common. So the brackets turn out to be the same. So x plus 3 gets factored out, and x minus 8 is the remaining bracket. Okay, you have to think carefully about signs, numbers, everything else. Okay, let's talk about this one. Factor out 16. 1 into 16, 2 into 8, 4 into 4. Now I need two numbers. When added and subtracted should give me minus 8. So those are the two numbers that can give me minus 8. 4 and 4, nothing else. So x square minus 4x should give me minus 8. What is common to the first two? X. What is common to the other two? Minus 4. Okay, this can also be written as, let's think about 10. 1 into 10, 2 into 5. That's it. After that, I start repeating myself. What two numbers will get me 11? These two numbers will get me 11. So let's break up 11x into 1x and 10x. 1x is just x. Okay, what's common to the first two? X. I'm left with x plus 10. What's common to the other two? There's nothing common, so there's one common. Left with x plus 10 and x plus. Okay. Then this next exercise is here to teach you how how a change in signs can influence your answers. Okay, so I see the last number is 6. 1 into 6, that's 2 into 3. Now I have to think of two numbers that when added or together should give me minus 5. Okay, but when multiplied should give me minus 6. As I stated, this should give me plus 30, not just 30, plus 30 here. So I should get minus 6. Now, if I pick up these two numbers and let's say I think of the numbers minus 2x and minus 3x. Minus 2 and minus 3 when multiplied together don't give me minus 6. They give me plus 6. Okay, so that's a challenge. So I have to pick up the other pair. What is the other pair? The other pair is 6 and 1. Can I arrange 6 and 1 in such a way? Yes, I can do that. Minus 6x plus 1x minus 6. Now do I have pairs? Yes, I have pairs. X minus 6 plus 1 and x minus 6. If you end up picking the wrong pair of numbers, you will realize that these brackets don't turn out to be the same. That is your hint to go back and reconsider what you've done. Okay. Similarly, I want a minus 6, but I want a plus 5 in the middle. Okay, so I'm going to say that they're the same factors, but instead I have the opposite signs now. X is common, and minus 1 is common. X plus 6 and x. But this one, if I use 1 and 6, it's never going to give me minus 5, and multiplied by each other should give me 6. The only way that I can get a plus 6 is 1 into 6. But I can also do minus 2 into minus 3. That is the only way that I can get a plus 6. You see all these other questions at minus 6, which is why I was having to deal with the first set of factors that I pointed out to you. What's common? X is common. What's common? Minus 3 is common. Okay. Then let's make this a little more complicated. It says to factorize a quadratic expression whose x square coefficient is not equals to 1, we can use the method of pairing. To factorize 6x squared plus 11x minus 10, we need two numbers whose sum is 11. That's the stated thing. That's fine. You're trying to break the middle term. But let's look at this. And whose product is equals to plus 6 into minus 10. Which means that you must now also consider this. So far in all the questions, you already had 1x squared. Now you have 6x squared. So that's what you need to consider. Now the two products are 15 and minus 4. They've come up with the factors 15 and minus 4, and then they've done factorizing by pairing. Let's see how we are going to do that. Let's start with one of these questions here and say that I want to do A. Okay, 2 and 15. So 2 and 15 get me 30. Okay, so what I have is 2x squared plus 13x plus 15. So I'm going to multiply 2 and 15 together and say that this is 30. Now I need factors of 30. So 1 into 30, 2 into 15, 3 into 10, 5 into 6. Those are all the factors of 30. I need to pick a pair such that I get plus 13 by adding or subtracting them. And I need a plus 30 here as well. Uh, Okay, I need a plus 30 here as well. Okay, so I could have picked up 15 and 12, but that doesn't give me. I'll have to keep one as a positive and the other as a negative. So what I'm going to do is I'm going to take 3x and I'm going to take 10x. So that they give me a plus 30, and when multiplied together they get me a plus 30, and when added together they give me a 13x. Okay, remember that plus 30 is also necessary. If you had picked up 15 and 12, you would have had to do 15x minus 2x. In that case, that wouldn't have turned out to be plus 30. When you multiply 15 and minus 2, you get minus 30. What's common to the first 2x? So 2x plus 3. Common to the other two, 5. 2x plus 2x plus 3 and x plus 5. Okay. 4 into 35. 4 into 35 is 140. I will have to factor out factors of 140. 1 into 140. 2 into 70. I don't think it divides by 3. Divides by 4 certainly. 4 into 35. 5 into 140 divided by 5 is 28. Not 29. 8. Okay, I don't think this goes into 6. 7 into 20. I don't think it's going to divide into 8 or 9 and then 10. So I think the most viable factor is 10 and 14. I'm going to say 4x square minus 10x minus 14x plus 35. Common is 2x, so 2x plus 5. 2x minus 5. Okay. Then minus 7, 2x minus 2x 5 and 7. Okay. Let's look at C. I will have to rearrange this a little and say that this is 28. So minus 1 into 28 gives me minus 28. So I break up the factors 1 into 28, 2 into 14. I can't divide by 3, 4. Minus x squared plus 7x minus 4x. Minus x, so you get x minus 7. Minus 4 and x minus 7. So x minus 7 and minus x minus 4. Okay. Let's do this one as the last bit. Now this is different. How is this different? Because you have both x squares and y squares. But see, if I follow the same process, I'm still going to be able to break the middle term. What's 8 into 15? Let's first do that. 120, so that's plus 120. Let's start breaking up 120. 1 into 120, 2 into 60, 3 into 40, 4 into 30. Okay. And 5 into 24, 6 into 20. I think 6 into 20 gives me my desired 26 in the middle and 120 at the end. Remember that 4 and 30 won't work because it's going to give me a negative 26 if I put that up. Okay, so 8x squared plus 6xy plus 20xy plus 5y squared. Now the key to these questions is to remember that those brackets that you have will then turn out to be the same. What's common in these two? 4. 2x, no, sorry, 2 is common. So 2x. So 4x plus 3y. Then we have 5 common, 5y common. This is 15. 4x plus 3y. See, these two brackets have turned out to be the same, 4x plus 3y and 2x plus 5. Okay. E is the same. I'm going to do F as the last one for today. In fact, I do have, in fact, that's a practice exercise that you should do on your own later on. Okay, what's 6 into 25? 6 into 25 is 150. Let's start breaking up 150. I think this is going to divide by 4. 5 into 30. I think I have, no, I don't have enough right now. I think it's going to go into 10 into 15. So I'm just going to speed that up and say that this is 10xy plus minus 15xy plus 25. 2xy, so 3xy minus 5 minus 5, 3xy minus 5. 3xy minus 5 and 2xy minus 5. I think I made the brackets correctly. 6x square y minus. Yeah. Okay. So those are the correct answers. I hope this session was productive for you. There is an exercise that you could do for practice. I would strongly encourage you to do this. And this comes up in the exam as it is. You've seen some past paper questions as well. They were here up top. More complicated past paper questions coming up later on. We'll talk about those in the next video. Thank you for watching.